No, you would have known. Okay, so our first lesson is on similar polygons or similar shapes. Based on my little hints here, what do you suppose a similar polygon is?
Like Instagram symbol.
Can't hear. Turn it down.
What do we notice about the two Snapchats? They're the same, but what?
Different sizes.
Different sizes. Do you guys know the guy on the right?
Yes. Oh, on
the top right?
Oh no.
No, who's that?
Come on, guys.
Who is that?
That's
Patrick Mahomes.
Sammy Watkins?
Yes, please.
No, Kareem Hunt.
He wasn't the MVP for the
Oh,
Super Bowl?
Damian Williams.
Oh, stop it. What about the guy on the left?
Mayor Brown.
Mayor Brown.
Oh, that's
it.
Roger
Bill
Goodell.
Belichick.
Roger
Did he
Goodell.
deliver anybody in here? Mayor Brown, he's a doctor. Yeah? Look at this. Celebrities in
Bill
here.
Belichick.
Ooh.
They were delivered by the mayor. He's a baby doctor.
My mom's a little bit.
Actually? Oh, that's hilarious.
I didn't know.
No, Bryce's just trying to flex how righteous they are.
Alright, let's fill in the blanks
Bryce,
here.
you get it. Your mom's a doctor.
So, again, similar polygons are the same shape with different sizes. And we have two things that must be met in order for things to be similar. Corresponding angles need to be congruent, or the same, and corresponding sides are proportional. And all the corresponding word means, you guys, they're just in matching spots. And you'll see what that looks like in a moment. But they're just in matching spots. That's what corresponding means. The ratio of your corresponding sides is your scale factors, like how much bigger or smaller your two shapes are to each other. That's last one. If the polygons are similar, then their perimeters are also proportional, which makes sense because if your sides are the same, your perimeters will also be the same ratio.
Oh, why is there a picture of a drill?
Are you guys taking notes?
Yeah.
Okay. It's hard to say from this view.
Oh. Is that what the skill is?
You typically leave it as a fraction, though. Am I okay to go on? Okay. So let's break this down. Do we have three pairs of congruent angles in this example? Yes. Like A matches D, right? One archy mark. Two archy marks B and E, and C and F, right? So I'm going to put angles with a check mark that I check that my angles are congruent. So that's my first thing we met. And now, sides being proportional, so they have to reduce to the same ratio. So what I like to do is I like to pick my small triangle first, and then the smallest side on that triangle. So what's my smallest side here? 8, right? Now what's my small side over here? 12. How does that reduce? What goes into 8 and 12? 2/3, right? Because 4 goes into both. Is it 8 divided by 4 is 2. 12 divided by 4 is 3. Okay, so we did our small sides. Now let's check our medium side. So my medium side here is 10. What's my medium side out of these three? 10 and 15. How does that reduce? So far, so good. Because if these don't match, then they're not similar. So far, everything's working out. And then our last one, 18 over 27. Does that reduce to 2/3?
Yeah. Yes.
Because 9 goes into both, right? All right. So now these are similar because our angles are congruent and our sides are proportional. So what is the scale factor from triangle ABC to DEF?
2 to 3/3.
2 to 3. Yep, 2/3. What if we went the other way? What if it was DEF to ABC? Just 3 over 2. You just flip the order. That's it.
So if you go from small to big, it's small over big.
And if they want big over small, just the big number on top. That's all. What is the ratio of the perimeters? Will you guys add these up? Where are all 3 of those added together?
36.
36. So that's for ABC. What about for DEF? 54. You guys agree? 54? So if I want to reduce 54 over 36, oh boy, what goes into 54 and 36?
6.
8, 9. 8 doesn't. 9 works. What? No, 9 doesn't. Oh, 9 works. What's 54?
36
Three
over
seven
4.
over
3 over 6.
Which goes into
3 over 2.
4 is.
If you divide them both by 9, you get 4 over 6. And you can
3 over
reduce
7.
that.
If I divide by 9, I get 4 over 6 over 4. I have a big number on top. And then we can divide by 2 again. So what do we notice between the ratio of the perimeters and the scale factor? The same. Want to write yourself a note? They're the same. The ratio of your perimeters and the scale factor are the same. Then we have a similarity statement, like a congruent statement. So when we had congruent triangles, it was an equal sign with a little squiggle on top. A similarity statement is just the little squiggle. So that's your symbol for similar. It's just a little squiggle that was on top. So if I said triangle BAC is similar, what order would I have to go in for the other guy? What matches B? E. What matches A? D. Yeah. There you go. So triangle BAC is similar to triangle EDF. We okay? Sort of? Kind of? Okay, list all congruent angles and write a proportion that relates all the sides. So just like when we had congruent triangles, this is like your little key, right? So if I want to say angle J is congruent to what angle? P, so the first one goes to the first one. So I'm going to write angle J is congruent to angle P. Angle K is congruent to angle M. Yep, and then L to N. Yeah, this next thing's gonna look goofy, okay? Put like a fraction bar with an equal sign, at the fraction bar with an equal sign with one more fraction bar. It looks really goofy, and we'll just fill it out together. So now we have to match our sides. So what would JK match? PM, right? So JK corresponds to PM. And if I keep working around to MN, yeah. And then our last one, JL and NP. So why is this important? This will be important to help us solve for missing lengths, which is what we're going for our last example. So we are given the two triangles are similar. Find the value of x. So we just have to match. So if I pick AG, what does AG match? KX, right? So I'm at 32 over x plus 3 is equal to GM, which is 36. What does GM match?
X plus 6.
Yep, x dx plus 6. This might be like a review from 7th grade. Remember how to solve a proportion? Yeah, cross multiply, right? You kind of do like that butterfly thing. I'm going to have 32 times x plus 6. Set that equal to 36 times x plus 3. Now, does that kind of look familiar, or has no one ever done that before? Then we just have to distribute. You guys will have to help with these numbers. We'll have 32x. What's 32 times 6? Calculator.
Times 6.
Yeah.
192.
192 equals 36x, and then 36 times 3 is
108.
bring our x's to one side and our numbers to the other. So 192 minus 108 would be, what, 84 equals 4x. X equals